Let's take a look at your test for review. Problem number 1. A newspaper provided a snapshot illustrating poll results from 1910 professionals who interviewed job applicants. The illustration showed that 26% of them said the biggest interview turnoff is the applicant did not make an effort to learn about the job or company. The margin of error given was plus or minus 3 percentage points. What important feature of the poll was omitted? Well, I don't see. Let's see what we have in here. This was from 1910 professionals, so there's an N, maybe, yeah. 26% of them said, that's your p-hat, that's your point estimate. Plus or minus percentage points. Plus or minus 3 percentage points, that's your margin of error. It appears that the confidence level is not there. It doesn't say like 95% confidence level or something to that effect, 90%, 99%. So that is definitely not in the poll. All right, next question. Find the critical value z sub alpha over 2 that corresponds to the given confidence level. Confidence level of 89%. Okay, so 89% confidence level means we have an alpha equal to 1 minus 0.89 or 0.11. All right, so z sub alpha over 2 is z sub 0.11 divided by 2. Okay. All right, so this is what I need to look at as far as area goes. We want that much area to be to the right of our critical z. So if we were looking under the bell curve, we want this area right here to be 0.055 right there. So the easiest way to do that is to actually look up the z-score for the area of all of this. So 1 minus 0.055 or 0.945. So we need to go to our z-score chart. All right, pull that up. And we're looking for the area, so there's stuff on the inside. It's 0.945, the closest we can get to that. All right, so there's 0.93, 0.94, 0.952. That's really close. Probably not going to get any closer than that. That's going to be 1.60. This is the 0 column, so 1.60. So our critical z for this is 1.60. You can see right here, 1.60. All right. Express the confidence interval. Here's the interval, the CI, in the form p hat plus or minus e. Okay, so the way that we have this given right now is this is p hat plus e. This is p hat minus e. So we want to write this in the form p hat plus or minus e. So we need to figure out p hat, the point estimate, and e, the margin of error. So to do that, there's a formula I can use. I know it, but I'll show it to you as well. So if we have the confidence interval, how can we figure out the p hat and the margin of error? Okay. To find the point estimate, we say the upper confidence limit plus the lower confidence limit divided by 2. To find the margin of error, we say the upper confidence limit minus the lower confidence limit divided by 2. All right, so let's find that real quick. All right, let's go back to our problem. So this is the lower confidence limit. This is the upper confidence limit. We said that p hat is going to equal the upper confidence limit plus the lower confidence limit divided by 2. The margin of error is going to be the upper confidence limit minus the lower confidence limit divided by 2. All right, so let's see what that is. So 0.333 plus 0.111 divided by 2. So p hat is 0.222. The margin of error, 0.333 minus 0.111 divided by 2. So it's 0.111. All right, so the problem asks us to write that as p hat plus or minus the margin of error. So that's 0.222 plus or minus 0.111. Okay, let's go to the next problem. Number 4. Express the confidence interval, 0.043 and 0.105, in the form p hat minus e is less than p hat plus e. Well, that's what each one of these, this lower limit is p hat minus e, and this upper limit is p hat plus e. So I don't have to find those, they're already in the problem. So the way that I would write that is 0.043 is less than p is less than 0.105. So I didn't actually have to find the p hat and the e. They were already, I have the sum here and the difference here, so all I do is just copy it down. All right. Use the sample data and confidence level given below to complete parts A through D. So Just kind of putting it all together here. All right, find the best point estimate of the population proportion P. This is problem number 5A. All right, so remember this is a proportion. So what that means is that's going to be like a x divided by n, so a part over a total. Let's see an R problem here. It says, so we're looking at a research poll, asked respondents if they felt vulnerable to identity theft. In the poll, n equals 1,042, x equals 566, and it says 566 who said yes. We're going to use a 99% confidence level. All right, so p hat is 566 divided by 1,042. All right, the answer here says round to 3 decimal places, so let me show you how to get that answer. 566 divided by 1,042. All right, if you round it to 3 places, 0.543. That's your answer. Okay. Part B, identify the value of the margin of error. So remember the formula for margin of error. For a proportion, margin of error is equal to z sub alpha over 2 times the square root of p hat times q hat divided by n. All right, so our margin of error, we need to know the critical z-score. The confidence was a 99% confidence level. That's a common confidence level. The 3 most commonly used are 90%, 95%, and 99%. So if you look at your z-score chart, and you look at the bottom of the positive z-score chart, you'll see down here common critical values. So that's 90%, 95%, 99%. So instead we were using a 99% confidence level. So I use a critical value of 2.575. 2.575. That's my critical z. Times p hat. Well, I know whenever we wrote in p hat on the previous problem, or the previous step, that we rounded it, but I would suggest keeping it as exact as possible. So what I'm going to do is I'm going to put it as this fraction right here. That's what p hat was before I rounded. And we don't like, it's not good to plug rounded values into formulas, which I'm sure you already figured out. So that's p hat. Q hat is 1 minus p hat. So if you say 1 minus this, what would you get? Let's see. We basically just say 1042 minus 566, and that gives me the numerator. So 476 over 1,042. That's q hat. Divided by the total. The total was 1,042. So the way that I would do this, you say 566. Actually, what I would do is I would put this in parentheses. Notice how the Windows calculator does this parentheses stuff up here. It will tell you so you can kind of see what you have and if that's the way that you are trying to do your calculation. So if I say this fraction times 476 over 1,042. So you can see I have this fraction times this fraction. And then we'll say divided by 1,042. All right, and so that's what's under the radical. Take the square root of that, square root, and then we have to say it times 2.575. All right, so this is our margin of error. And this says round to 4 decimal places is needed. So 1, 2, 3, 4 decimal places. So 0.0397. That's the margin of error. Now it says, that's part B. Now part C, construct the confidence interval. All right. So to construct a confidence interval, we say p hat minus e is less than p hat plus e. So again, I really don't like plugging rounded values into the calculator, so I'm probably going to say, I guess I have to though, since I figured out this margin of error, unless I save it in my calculator. But we want to take this value and we want to subtract, let's see, we want to take p hat and then subtract this margin of error. So I have 566 divided by 1,042. Now I want to subtract 0.0397 and round this to 3 places, 0.503. So 0.503 there, less than p, less than. Now I want to say p hat, which was 566 divided by 1,042, plus the margin of error. And so I get, if I round to 3 places, 0.583. All right. And so you can see the correct answer there. Write a statement that correctly interprets the confidence interval. Choose the correct answer below. All right, the correct answer is part A. One has 99% confidence that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion. It doesn't mean that there's a 99% confidence that p hat is in here. It says there's a 99% confidence that the true value of the population proportion is in there. Okay? A little different. It's important that you do understand that. Makes these problems go a little bit easier if you do. All right, let's look at problem number 6. A clinical trial tests a method designed to increase the probability of conceiving a girl. In the study, 350 babies were born. Okay, so that sounds like an N. 280 of them were girls. Use the sample data to construct a 99% confidence interval estimate of the percentage of girls born. Based on the result, does the method appear to be effective? Okay, so we need to figure out p hat, the population proportion. Then we need to figure out the margin of error. Once we get those two, we can figure out our confidence interval. All right, so p hat is x divided by n. So part over total, or 280 over 350. Hopefully that'll come up to be a pretty fraction. Let's see. 0.8. That's about as pretty as they get. All right, that fraction comes out to be a pretty decimal, a terminating decimal. That's good. All right, now 99% confidence level. So when we find our margin of error, our z sub alpha over 2 is going to be the one we use for 99%, which is the same one we used on the last problem, 2.575. All right, that times p hat is 0.8, which would make q hat 1 minus 0.8, or 0.2, over n, the total number. All right, so let's use a calculator to find that. 0.8 times 0.2 divided by 350. Take the square root of that and say that times 2.575. All right, so there's the margin of error. I would round that to 3 places, at least. So I'm going to round that to 0.055, and I'll stop there. I think that should be good. If for some reason you don't get the correct answer, then you might want to bring that out a couple more places. I mean, I don't expect you to bring it out all the way, but you know, if you want to do 5 or 6, it wouldn't hurt. Let's see what this does for us, though. All right, so to construct the confidence interval, I have p hat minus e is less than p hat plus e. So p hat is 0.8, so 0.8 minus 0.055 is less than p is less than 0.8 plus 0.055. All right. So I have 0.745 is less than p is less than 0.855. All right, so 0.745 to 0.855. Does the method appear to be effective? So that means we're 99% confident that the actual percentage or proportion, our sample was 80%, or 8.8, but we're 99% confident that the actual percentage is between that 74.5% and 85.5%. That sounds pretty reasonable. It's above 70%, so I would think that the method was effective. Okay. All right. Do one of the following as appropriate. Find the critical value z sub alpha over 2, find the critical value t sub alpha over 2, or state that neither normal nor the t-distribution applies. Okay? So it's really going to depend on a few things, right? It's going to depend on whether or not we know sigma, or, you know, is the population skewed and we don't know sigma? Is the population approximately normal and we know sigma? Or vice versa. So we have a lot of things to look at. Okay, so here are the requirements. We know the requirements for a z distribution. That's what we've been doing all along. And then here comes a type of distribution that's a little different. This is in Chapter 7, Section 3. And that would be with a t-distribution. So how do we know if we have a t-distribution? Well, the sample must be a random sample, and either or both of these conditions are satisfied. The population is normally distributed, or n is equal to 30. So I know it says n divided by 30, but that's a typo. So n equals 30. All right, so let's take a look back at the problem. So n equals 25. Oh, that's not 30. Population appears to be very skewed. That means that it's not normal. So if it's not normal and n is less than 30, then that's two bad things. So we know it's not a t-distribution. Well, z-distribution, it's skewed, it's not very normal. So it's not a z-distribution. So it's neither a t-distribution or a z-distribution. Okay. Right, here is problem number 8. It looks like we need to, it says construct a confidence interval using the given confidence level. Do whichever the following is appropriate. A, find the critical value z sub alpha over 2, or B, find the critical value t sub alpha over 2, or C, state that neither the normal nor t distribution applies. All right, so n equals 300. Sigma is unknown. Population appears to be skewed. So this isn't good that it's skewed, but we do have an n of 300 where sigma is unknown. So that means that we can use the t distribution. So to use the t distribution, let's see, we're just finding the actual critical value. That's what we're finding in this problem. So for a 90% confidence level, let's see, what would alpha be? So for a 90%. Alpha is equal to 1 minus 0.9, or 0.1. Now, if we're looking for z sub alpha over 2, that means we want the critical t-score, z sub 0.1 divided by 2. Remember what we're actually doing by dividing this by 2, we're getting the area in one tail. So, let's see what that be, t sub 0.05. So, just like with the z-score, that's the area in one tail. So, this actual area we want to be 0.05 is in this one tail. And there's one over here as well, it's 0.05. But usually, we're just dealing with this one, because that's just the way these problems work. Now, so we need to go to the t-distribution chart. The t-distribution chart is the one that is located right after the z-distribution chart. And with this chart, we have area in two tails or area in one tail. So, and you can see the area in one tail is 0.05, area in two tails is 0.10. That's just doubling. That's what all these are doing, actually. It's just doubling. So, if we divided by 2 to get that area that we wanted in our right tail or left tail, then if we said 0.1 divided by 2, we got that. If we just take the 0.1, the area in the two tails, we're still here. So this is the column that we'll use. Again, that's because our alpha was equal to 0.1, which is the area in two tails. By finding t sub alpha over 2, on this problem that became t sub 0.1 divided by 2, or t sub 0.05. So that's why we're using this column. Okay. Now degrees of freedom are, the way you find degrees of freedom, you say n minus 1. So whatever your n is in your problem, your data items, total data items, you subtract 1. Well, that works out pretty good until you get to these big numbers, like 200, 300, 400. So once you get that high, we just kind of have to guesstimate. In our problem, we had 300. Well, so 300 minus 1 is 299. Sorry about that. So there's no 299 here, so we have to use 300. That's our only choice for this table. Now remember which column we were in? We're in this column right here. So 300 over to that column is 1.650. So that is your critical t-score, 1.650. So my critical t, 1.650. 1.650 right there. All right, let's look at the next problem. 12 different video games showing substance use were observed, and the duration times of gameplay in seconds are listed below. The design of the study justifies the assumption that the sample can be treated as a simple random sample. Use the data to construct a 99% confidence interval estimate of mu, the mean duration of gameplay. All right, so this is a t-distribution. So we weren't given, any kind of sample values. We weren't given the things that we would need for this to be a z-distribution. All right, so since this is a t-distribution, we have x bar minus the margin of error is less than, population mean is less than x bar plus the margin of error. Okay? Now we're going to have to find x bar for the set of data. So we just need to look at the set of data and find the mean. That's going to be our x bar. Also, if you look at the formula for the margin of error, since we're not dealing with a proportion anymore, we're dealing with mean, sample mean, population mean. So we have our t-distribution. This is our critical t-score. Remember, degrees of freedom is going to be n minus 1, so we have to count the number of data items. What is this lowercase s up here? It's been a while since you've seen that. That is sample standard deviation. So I didn't see a sample standard deviation anywhere in that problem. We're probably going to have to calculate that. All right, and then I have that over the square root of n, where n is the number of data items. Okay? So let's see. All right, so I know that I have a 99% confidence interval. So remember, what does that mean? 99% confidence interval tells me that alpha is equal to 1 minus 0.99 or 0.01. So the area in two tails is 0.01. If you divide that by 2, which we will have to find our critical t-score, remember it's alpha divided by 2, so it's t sub, that divided by 2 is 0.005. So if you look at the column that has one tail with an area of 0.005, then that's going to be the same as two tails, 0.01. That's the actual column that we'll use in our table. Degrees of freedom, well, we need to count how many data items we have. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data items. So in my problem, I know that n equals 12, so my degrees of freedom, n minus 1 equals 12 minus 1, or 11. So we need to make sure we use that row in the table. Degrees of freedom 11, and then we said the column we would use would be the one that says 0.01 in two tails, or 0.005 in one tail. So let's pull up the table. All right. So 0.01 in two tails, or 0.005 in one tail, that's our column. That's because we had a 99% confidence interval, and the confidence interval of the alpha is 1 minus 0.99. So alpha would be 0.01, which is the area in two tails. Divide that by 2, you get the area in one tail. Our degrees of freedom was 11. So we have a degrees of freedom of 11. And so that would give us our critical t-score, 3.106. All right. So our critical t is 3.106. All right. So the only other thing that we will need for our margin of error is, we have n is 12. Remember, margin of error for this type of problem is critical t-score times sample standard deviation divided by the square root of n. So we have n is 12. We have the critical t-score. We just need to find the sample standard deviation. Now, instead of taking 15 or 20, instead of taking a long time to do that, I'm going to just use a calculator and plug these values in. So here's my data set right here. So I'm going to put this in the calculator. So I'm going to type all of these in real quick. May not be as quick as I would like, but that's okay too. All right, so trying to get these lined up. All right, 4053. 3888. 3864. 4033. 4319. 4815. 4649. 4023. 5007. 4819. 4336. And 4323. All right, so there's my data set. All right, so I want to figure out the sample standard deviation. So I need to go to stat, and then over to the right one is calc, one variable statistics. And now I want that for list 1. All right, and so our sample standard deviation, this right here, is 393.581333323. You know, that's as exact as they gave it to me, so when I plug it in my calculator, that's as exact as I'm going to keep it. All right, so sample standard deviation is 393.5813323. All right, and so now I can calculate my margin of error. That's going to be 3.106 times 393.5813323 divided by the square root of, what was n? 12. Okay, so I'm going to now, let me go back to my simpler calculator. All right, so I'm going to take this and divide first 393.5813323 divided by, and I'm going to put the square root of 12 in parentheses. So 12 square root equals, so that is this part right here, and I have to say that times 3.106. All right, so there's our margin of error. I'm going to take it out a few places to try to cut down on any rounding mistakes. So 894.849. That looks good. All right, and so the way that I construct my confidence interval, I'm going to have to use the mean, the sample mean, which I don't have yet, plus or minus the margin of error. So I'm going to have to go to that set of data. Luckily, I didn't close my calculator. X bar, there's the mean right there. 4344. X bar is 4344.083333. All right, so I'm going to take X bar and add the margin of error and X bar and subtract the margin of error, and that will give me my confidence interval. Okay, so X bar, this value right here. So 4344.083333 minus the margin of error, 352.894849. And this is where we round. I know we have both of these already rounded, but we round to 3 significant digits, I believe, or just 3 digits. So this bottom boundary here is 3991.188. All right, and the upper boundary we say X bar plus E. So 4344.083333 plus 352.894849. And so the upper bound is 4696 point, around to 3 places, 978. Okay. All right, come back to my problem. Well, they rounded to 1 place, so I didn't get it wrong as far as all my calculations, so that's good, but I rounded wrong. So always read the directions. Let's see. If I round to 1 decimal, that means I'm down to rounding right here, so this will be 3991.2. And 4696 point, oh, well, that was a 9, so that's going to go up to a 7. All right, and so that is my confidence interval. All right. Let's move on to the next problem. Problem number 10. All right, so we have 2 sets of data here that we are going to look at. A physician wants to develop criteria for determining whether a patient's pulse rate is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample pulse rates below. All right, we want to construct a 95% confidence interval estimate of the mean pulse rate for males, and then we're going to do the same thing for females. So we'll work it out once for males, work it out once for females. So I'm going to use this fancier calculator here to get the sample standard deviations, because that just saves a lot of time, which I'm sure those of you who do use the technology know. Those of you who don't use the technology are probably saying, man, you mean I could have used that? I'm sure that most of you use it, though, because it does take a while as the numbers get larger. So I'm going to have to figure out a critical t-score for both of these. If I want a 95% confidence interval, I'm going to have to figure out, for the margin of error, of course, the t-score and the standard deviation. So let me go ahead and do that. So you find a little blank spot here. This is problem number 10. So first we're going to do this for males. So under male, the things that I will need, I'm going to need a critical t-score. All right, and for that, for 95%, that's going to be t sub 0.05 divided by 2, or t sub 0.025. And that's the same, luckily, for males and for females. So I'm only going to find this once. My degrees of freedom for that, I need to count how many data items I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 for each. All right, so my degrees of freedom is going to be 10 minus 1, or 9. My n is going to equal 10. What else do I need? I need the actual critical t-score, and I need a sample standard deviation. And I should be good to go. I should be able to calculate my standard deviation. Let me go ahead and find the critical t-score before I start playing on the calculator. So I need to go to the table. Remember, it's right after the z-score table in Appendix A. All right, so remember our, let's see, we had a 95% confidence level. So that means that the alpha would be 0.05. That's the area in two tails. So the area in one tail would be 0.025. So that's this column. We had 10 data items. So our degrees of freedom is 10 minus 1, or 9. So that means that our critical t-score is 2.262. 2.262 is our critical t-score. Okay. Now let's find our sample standard deviation, and once we do that, we'll also use the calculator and just look at the mean of the set. Okay. So I cleared out those items there. Let me find my data set. All right, so I'll space these as best I can, but we'll see. I'm going to have to go back and forth a couple times. Okay, so I need to go to Stat, Edit, and I'm going to edit this first list where I just work the problem. You can just go up to L1 and hit Clear, and it shows L1 equals nothing, so if you hit Enter, now L1 is gone. Okay, so let's put these numbers in here, into my list for males. So 96, 88, 56, 56, 56, 64, 84, 64, 68, and 64. All right, so there's my data set. I'll go to Stat, Calc, one variable statistics, and that is for list 1. All right, so this is the data for males. So my standard deviation, sample standard deviation, I'm going to carry this out a couple places, is 14.50823, and my mean is 69.6. Okay, so I'm going to use that to help me figure out my margin of error. My margin of error, and this is for a mean, standard deviation, population standard deviation unknown. You say critical t-score times s over the square root of n. So my critical t was 2.262, and that times my standard deviation divided by the square root of n, and n was 10. So this will give me my margin of error. Okay, let's see what this is all about. Okay, so that's what I got whenever I divided there. And I'll say times 2.262. All right, so my margin of error, and I'm going to carry this out a couple places, is 10.37784. And so now I can construct my confidence interval. Remember, the confidence interval is x bar minus e is less than mu is less than x bar plus e. So we say 69.6 plus, or I'm sorry, minus, I'll do that one first. The margin of error was 10.37784. I should probably see how many decimal places this problem wants me to round to. Looks like one more than the data set, I guess. So we'll round to one place. So this number here, the lower, is 59.2. And the upper is 69.6 plus the margin of error. All right, I'm going to round this to one place, so 80.0. Okay, let's look back at my problem, see if we got the right answer. Yes, we did, 59.2 and 80.0. All right, So that's how we find the males. To save a little time on this one, I'm just going to write down what we would use to find the female. All right, and probably won't work that one out all the way. That way, if you want to do a little practice with this, you can pause the video and see if you can get the answers. It looks like the n stays the same because we have 10 new pulse rates. The degrees of freedom is going to be the same. It's going to be 9, but we really don't need that because we've already figured out the critical t-score. The critical t-score is going to be the same because we have the same confidence level and the same degrees of freedom. So there's that. And so the main difference is this right here. You got to find the sample standard deviation for the female set of data. Okay, so figure that value out. I suggest using technology if you can. And once you do that, then calculate the margin of error. Once you have that, you need to find a new mean of the data set. You get those two values, then you can construct your interval, just like we did for males. And so now would be the time you'd want to pause it if you want to try to work that out. If not, just keep going. And it looks like your confidence interval is 71.4 to 98.2. Part C says, comparing the preceding results, can we conclude that the population means for males and females differ? Do these intervals overlap? It looks like they do a little bit, right? This top end is 80, this bottom end is 71. So these intervals would overlap. So I wouldn't think that they would be different, really, because there's a chance that they're the same. Let's see. No, because the two confidence intervals overlap. We cannot conclude that the two population means are different. All right, so that's why. And that's problem